This will be for the Khan Academy exercise, strategy and finding limits. All right, so just a quick reminder of the three possible outcomes when you use direct substitution. You found a limit, so you got an actual number. The limit does not exist, non-zero over zero. And if you get 0 over 0, it's indeterminate, and you have to do more work. All right, so they basically give you a limit problem, and they give you a flow chart here, and then they want you to indicate the steps and the order of the steps that you used. So I think the best bet in most cases here is just to solve the actual problem and then record what you did. Okay. So as you can see from the steps, you're going to use direct substitution first. And then either it's one of those three that I just went over. A number over zero, you get an actual number, or you get 0 over 0. Like we said, if you get 0 over 0, you have to keep going. So if you get 0 over 0, you keep going. We learn factoring, we learn conjugates, and we learn trig identities. You're going to try one of these three, depending on what's appropriate, and then go back and use direct substitution again and see what you get again. So that's basically it. All we're doing is finding the limit, but we're using all three possibilities here: factoring, conjugate, trig identity. So once again, I'm using Paul's online math notes. The important ones here: the tan is sine over cosine, and the cotan is cosine over sine. Pythagorean identities, with the main one being sine squared plus cosine squared is 1. And also we have the double angle formulas right here. Those are the main ones we're going to use. All right, so here we have the limit as x approaches negative pi over 4 for this function right here. I'm pretty sure it's going to be 0 over 0, but let's plug in negative pi over 4 just to make sure. All right, so we have the cosine. We're plugging in x equals negative pi over 4 wherever you see an x. Okay, in the numerator, it's going to be cosine, and that's going to be 2 times x. So 2 times negative pi over 4 is going to be negative pi over 2. Denominator, cosine x is going to be cosine of negative pi over 4 plus sine of pi over 4, or should I say negative pi over 4. Okay, I am going to do this on the calculator. You could use the unit circle or the calculator. Make sure you're set to radians. All right, so doing the numerator and denominator separately. In the numerator, I got 0, and in the denominator, I also got 0. So that is in indeterminate form. Okay, which means we have more work to do, which I figured would happen. So I'm going to apply the double angle formula here in the numerator. All right, for the double angle formulas for cosine, there's actually 3 options here. Now, the numerator had both sine and cosine, so I am going to go with the one that has both cosine and sine in the numerator as well. I should say the denominator had both sine and cosine. So I'm going to choose the one with both sine and cosine. It would still probably work either way, but I'm going to go with this one. So cosine of 2 theta is going to be cosine squared theta minus sine squared theta. All right, so in the numerator, it's going to be cosine squared theta, or cosine squared of x. And that's going to be minus sine squared x. And keep the denominator, cos x plus sine x. All right, and I can see in the numerator we have a difference of squares. Okay, recall that a squared minus b squared is equivalent to a minus b times a plus b. All right. So a squared minus b squared is this right here. All right, notice the minus sign lines up. A squared is cosine squared of x. B squared is sine squared of x. So rewriting the numerator in this form, a minus b, let me see here. Just, I don't want to confuse people. If a squared is cosine squared of x, take the square root on both sides, and a is going to be cosine of x. All right. Also, if b squared equals sine squared of x, same thing. Take the square root of both sides, and b is going to be sine of x. Okay. So just use this formula right here. A is cosine x minus b, so minus sine x. A is cosine x plus b, so it's going to be plus sine of x. All right, so I rewrote the numerator, expanding the difference of squares using this formula. The denominator is the same, cosine x plus sine x. All right, these are both multiplied in the numerator, so we can cancel cosine x plus sine of x, top and bottom. All right, and now we can substitute once again with what we have left. X approaches negative pi over 4, so let's do that right here. Cosine, for the x, it's negative pi over 4. And minus sine of negative pi over 4. And now we should get an actual answer, okay? I just took this right here, subbed in negative pi over 4, and let me go to my calculator, set to radians. And I get 1.414, which is actually radical 2, okay, depending on your calculator. What you should end up getting here for cosine of negative pi over 4 is radical 2. And sine of negative pi over 4 is going to be negative radical 2. So radical 2 minus negative radical 2, that's going to be radical 2 plus radical 2. I'm sorry, this would be radical 2 over 2. And this would be negative radical 2 over 2. Okay, radical 2 over 2 minus negative radical 2 over 2 is going to be radical 2 over 2 plus radical 2 over 2, which equals radical 2. Doesn't matter anyway. We didn't even need an exact answer. The fact that you got an actual number means that it worked. Okay, so we did direct substitution. We got 0 over 0, which is indeterminate form. We used a trig identity and then tried again, and it worked. All right, so on the flow chart, we used direct substitution. That's A. And we got 0 over 0. That's D. And then what did we do? Well, let's see. All right, we did trig identities. And then we went back around. After trig identities, which was G, we did substitution again, and the limit was found. All right, so the trig identities was G. And then we used direct substitution, and the limit was found. So that was A and then C. All right, so we have to do that on the chart. All right, let's see. We did direct substitution, and we got 0 over 0. That was indeterminate form. And then we did a trig identity. All right, and then we tried direct substitution again. And then we found the limit. We got an actual number, regardless of whether it was a decimal or a square root. Hopefully that's it. Yes, very good. That was it. All right, here we have the limit as x approaches 0. Let's try direct substitution. So wherever you see an x, sub in 0, it's going to be 1 minus e to the 0. ln of 2 minus e to the 0. All right, anything to the 0 is 1. Wherever you see e to the 0, make it 1. In the numerator, 1 minus 1 is 0. In the denominator, we have 2 minus 1, which is 1. And the natural log of 1 is just 0. 0 over 0 is indeterminate form. We need to keep going. All right, so I'm having a tough time here. You can't really factor this or anything like that. So what you could do is approximate. Since we're doing the limit as x approaches 0, on the one side of 0, on the positive side, we choose a number that's a little bit bigger than 0. Let's say 0.01. And then on the negative side, we'll choose a number that's a little bit smaller than 0. Let's say negative 0.01. So I'm gonna use the calculator. You could graph it on your calculator or on Desmos. But what I'm gonna do is just try these two values right here because they're close to 0, but not quite. So let's sub in 0.01 in place of x. It's going to be 1 minus e to the 0.01 divided by ln of 2 minus e to the 0.01. Okay? And before I do that, I'm also going to write out 1 minus e to the negative 0.01. And that's going to be divided by ln of 2 minus e to the negative 0.01. All right, let me do these two on the calculator, see what we get. All right, perfect. I got 0.995 and 1.005. So clearly it is approaching 1. Okay, like I said, you can also graph this on Desmos and you'll see the same thing. All right, so we did direct substitution. We got 0 over 0. That was indeterminate form. And then we could not do the factoring, conjugates, or trig identities. We couldn't do any of these three. So we did an approximation. You either graph it or you plug in numbers around the limit on the calculator. When we did the approximation, let's see. When we did the approximation, I don't think that's considered direct substitution again, because we didn't plug in 0, we plugged in the numbers around 0. So after the approximation, the limit was found. I hope that does it. All right, so they said direct substitution, indeterminate form, and then approximation. I don't know why they don't say limit found, but I guess that was wrong in their eyes. All right, so I'll take the limit found and put that back. And those three apparently are the answer. I don't know why. All right, I did find the actual limit. I don't know why they marked that wrong. All right, I'm just going to guess at 1. Because this one here, I can tell it's going to be factoring. Okay, I'm just going to try and guess. Let's see what happens. Because I want to get to one where we use the conjugate. All right, so I bet you it was direct substitution. And you get 0 over 0, which is indeterminate form. And then you use factoring. Okay, because you can't use a conjugate or a trig identity. You use factoring. And then after you factor, you direct substitute again. And the limit is found. I'm almost positive that's going to be correct. Let's see. Whoops, let's see. Okay, I almost got it correct. I almost guessed it correct. After the factoring and direct substitution, they got an asymptote. Okay, they got a non-zero over 0, so they ended up with an asymptote. So the limit was not found, but it was an asymptote after direct substitution. All right, like I said, I just wanted to guess. I want to get one with conjugate. All right, one more. Limit as x approaches -1. Let's try substitution. We're plugging in -1 in place of x. That's going to be 1 plus the square root. 5 times -1 is -5, plus 30 is 25. So the square root's going to be 25. Plug in -1 squared. -1 squared minus 1. Okay, radical 25 is the same as 5. 1 plus 5 in the numerator is 6. -1 squared is 1, minus 1, that's 0. So that is a DNE, does not exist. All right, I was hoping to get a conjugate one. Just by the way, this one's DNE, but just by the way, if this had turned out to be a conjugate, instead of a plus sign there, you would do 1 minus the square root of 5x plus 30. And you'd have to do the same thing in the denominator, 1 minus the square root of 5x plus 30. Okay, the point of that would be to get rid of the square root, because when you have the plus minus and you FOIL, the inner outer term drops out. You would get rid of the square root, leave the denominator as is, and try the substitution again. But we got lucky and substitute right away. We got DNE. All right, so we did direct substitution, and then we said DNE does not exist. So that's really what they mean by asymptote. So if you get does not exist, that's going to be your asymptote. Hope this one is correct. All right, good. We got it.